Okay, so we're gonna get to solving quadratics by factoring. And for this type of problem, there could be different ways that it's going to ask the question. It could ask what are the solutions, which is basically just solve the equation. That's what you're doing when you're finding solutions, is you're solving it. But it also could say find the zeros, which you're going to be doing the same thing, or it could say find the roots of the quadratic or of the function. All of these are going to end up being the same steps, so it's important for you to understand the directions in order to know what to do, because you may know what to do in those scenarios, but if you don't know what the directions are asking, then you can't even start it. Okay, so any of those, we're going to be doing these steps. First, get everything on one side and have it equal 0. Then you factor the quadratic and use the zero product property to solve the equation. The zero product property says that if A times B is equal to 0, well, if you look at this, you have two things being multiplied equal to 0. The only way that can happen is if one of those two things is equal to 0. So you have if A times B is equal to 0, then A is equal to 0 or B is equal to 0. Okay? So basically what you do, I got to get everything on one side, subtract the 2x. I'm going to add the 4. I'm going to do this in the same step here. So I have x squared. This becomes negative 5x. This becomes positive 6 is equal to 0. I'm going to go ahead and factor this. And I get x minus 3 times x minus 2 is equal to 0. And at this point, you're going to use the zero product property, which says that if x minus 3 times x minus 2 equals 0, then either x minus 3 equals 0 or x minus 2 equals 0. So then you solve each of those, and I get x equals 3, I add 2, or x equals 2. And those are my two solutions, which means if I plug them back into the original, it would come out to be a true statement as the equation. So we'll do a couple more. This one's going to say find the roots of the equation. Again, it's the same type of question. So I got to get everything on one side first. So I'm going to add 6x and add 6x here. I can't actually combine these though because this is x squared and this one is just x. And there's no x over here for it to combine. So then all you need to be doing is putting it in the right order. Have your x squared first, then your x term, and there's no constant in this one, and equals 0. And so when you go to factor this one, remember to always check for your GCF, because I still have a lot of people getting stuck on this and not being able to figure out what to do in this situation and trying to do the t-chart or trying to do some factoring method where all you really have to do is factor out a GCF. If every term has an x or has a variable, you can factor out that variable. If there's no constant, then every term has a variable. So out of the 9 and the 6, my GCF is 3, but they each do have an x, so I'm going to factor out the x as well. And what I'm left with is 3x plus 2, and there's no x on this one. And now I don't have to factor it. I'm done because this is a linear. It's not a quadratic anymore. Okay? So I have this 3x plus 2 is equal to 0. Get in the habit of setting this up and solving it, because a lot of people will make the mistake is from these over here. Yeah, it just ends up being the opposites. And if you take those shortcuts, especially early on right now, I will have a lot of people making mistakes on that, because it's not always just the opposite of this one. Because in this one you have to subtract the 2, and then you're going to have to divide by the 3. So x is equal to negative 2 over 3. But I also have this 3x out here. And because it has a variable, I do need to solve for that one as well. Set it equal to 0. and I have x equals 0. So my solutions are negative 2 over 3 and 0. If this GCF does not have a variable, then you don't have a solution for that part of it because it won't be able to have that variable to solve for. If it's just a constant, you don't need to worry about that as part of your solution. Okay, so I'm going to give you a little you try here. Pause it. I'll give you the answers in a little bit. Give yourself some time to try it on your own and see if you're getting it right. This is a 5x squared plus 30x equals negative 12 minus 2x. So you end up bringing everything to one side. The 12 doesn't have anything to combine with, so you just leave it on the end. It factors into 5x plus 2 times x plus 6. However way you factor it, you should be showing your work still for that. And then you end up solving each of them and you get negative 2 over 5 and negative 6. So we're gonna move into complex numbers. And complex numbers is any number that has or expression that has the imaginary unit I. And I is never used as a variable because it represents the imaginary number or the imaginary unit. Anytime you see I, it means that that is multiplied with negative or the square root of negative 1. So if you have something like this, square root of negative 18, what this can be done is I can split the radical into the square root of negative 1 times the square root of 18. And then the square root of negative 1 becomes I, so it's I times the square root of 18. Now we are going to have to simplify these radicals, and you are going to have to do this without a calculator. I'm going to give you 3 ways to do it. You choose whichever way you like. Okay? So for the square root of 18, some of these smaller numbers you can use by using your perfect squares. If you know your perfect squares really well, you can do some of these smaller numbers this way. It gets a little bit more difficult when you have larger numbers. But what you're doing is you can break this number under the radical, which is called the radicand, up into more radicals, and you want to have your perfect squares. So what are perfect squares that go into 18? 9 is a perfect square, so you can break that up into square root of 9 times the square root of 2. And what that is that's still the square root of 18. And then simplify that. Square root of 9 is 3. 3 times the square root of 2. And that would be it. Another way to do it. The factor tree is something that you probably learned from Algebra 1, is you break down the radicand and start factoring it, 9 times 2, and then the 9 becomes 3 times 3, until you have all prime factors on the branches. And what you do is you find your pairs. I have a pair of 3s. What I like to do a lot of times is box the ones that don't have pairs. So I have a pair of 3s, and what happens is one of those pairs comes out, 1 3 is on the outside, and what doesn't have pairs is left on the inside. So that would be 3 times square root of 2, same thing I got here. And the last thing I do is the birthday cake. And this is the one that I like to do. This is pretty much the same as the factor tree, it's just a different way to organize it. And so I start with the radicand, and that's the base of the cake. The only difference with this one in the factor tree is that you have to use its prime factors on the outside. You have to divide it by prime factors. So you start with 2, 3, 5, and 7. Those are normally your early prime factors that you're really only going to have to use those. 2, 3, 5, and 7. So start with 2, 2 times 9, and then break down the 9, 3 times 3, and 3 times 1. And once you get the 1 on top, that's my birthday candle. Happy birthday! But from here, it's the same thing as a factor tree. Find your pairs. That comes on the outside. What doesn't have a pair is left on the inside. Okay? So when this breaks down into that, I have I times 3 times square root of 2. That becomes 3i times the square root of 2. And that's my simplified form. And so for this one, I do one more. Square root of negative 216, well, because of negative, it's going to be an I, so I times the square root of positive 216. Always check to see if it is a perfect square, but 216 is one that's this is where it comes a little bit difficult to do the perfect squares. So I'll do this one with the birthday cake. And throughout the notes, I'll do different versions of each kind so you can see them different ways. I always start with 2 if it's even and work my way up. If 2 doesn't go into it, start with 3, 5, 7. But start with 2 and divide it by 2 and I get 108. And I'm going to keep dividing by whatever I start with until it can't be divided by that anymore. So I have divided by 2 and I get 54, divided by 2 and I get 27, divided by 3 and 9, I'm coming to my end, 3 and 3, 3 and 1, and that's my birthday candle. Happy birthday! All right, so here I want to find my pairs. So I have a pair of 3s and a pair of 2s. So what happens when you have more than one pair is they get multiplied out in front. So I have 3 times 2 is 6 times the I, and what's left on the inside is this 3 and 2, and they get multiplied and go on the insides, and so that's square root of 6. So it simplifies to 6i times the square root of 6. And so with adding and subtracting complex numbers, all it is, you're using the same rules as if they were variables. Okay, so I have 5 minus 7i plus 2 plus 4i. I always like to rewrite it, especially at the beginning of learning it, without the parentheses. Okay, there's nothing being multiplied to the parentheses, so they stay the same, and now you're just combining your like terms. These are being added together. So 5 plus 2 is 7, negative 7 plus 4i, negative 7i plus 4i becomes negative 3i. So I have 7 minus 3i. That's it. With the subtraction, it is a little bit more difficult because you just have to understand that this negative is really a negative 1 that's being multiplied to this whole parentheses. So when you write it without the parentheses, it's 8 minus 4i, and this becomes minus 3 and plus 6i. You basically need to distribute that negative or that negative 1 into that second parentheses, or the one that it's in front of. So now I'm combining my like terms. 4 minus 3 is 1. Negative 8i plus 6i becomes negative 2i, and that's my simplified form. Okay, and so the last part has to do with I squared. And it's based off of the concept, if I do square root of 5 times the square root of 5, that becomes the square root of 25, which is 5. If I do the square root of x times the square root of x, becomes the square root of x squared. So if I'm taking the square root of something squared, it just comes back to x. So the idea behind it is, if I have the square root of negative 1 times the square root of negative 1, well, that's going to be negative 1. So what that means is, if I squared is equal to negative 1. And this is the concept that you basically just need to know. Anytime you have an I squared, it's always going to equal negative 1. Okay? So you're going to have to replace that I squared with negative 1. You should never... So for this one, I have negative 5i times 3i. Well, that's going to be negative 15. I times I is I squared. And the I squared becomes negative 1. So I get negative 15 times negative 1, which becomes positive 15. In this one, I have the square root of negative 6 times the square root of negative 15. Well, I can multiply those. You have to simplify it with the I first before you multiply them. So it's I times the square root of 6 times I times the square root of 15. And they can't simplify there. And now I can multiply them, and the I times I becomes I squared. 6 times 15 becomes 90. And this is one where the perfect squares works out pretty good. So I have the square root of 9 times the square root of 10, and the square root of 9 is 3. So it's 3i squared times the square root of 10. And the I squared becomes negative 1. So 3 times negative 1 is -3 times the square root of 10 is your simplified form. Okay, so go ahead and try these 5 real quick. You can simplify using any way, and I'll go over the answers in 5 seconds. Okay, so here are your answers. I did the factor tree here. There's a pair of 3's and a 3 left over, so the negative brings the I out, so it's 3i times the square root of 3. And number 2, I did the birthday cake. I factored by 2's and then a 5 and then 3's. So I have a pair of 2's and a pair of 3's. Multiply that with the I because it's a negative. And then the 5 times the 2 is on the inside. -3 times -4 is +12. I times I is I squared, which then simplifies to -12. And what I did here was I simplified each of these first using the perfect squares. Square root of 4 times I becomes 2i times square root of 5. The square root of -12 becomes 2i times square root of 3. And I can multiply those. You multiply what's on the outside, 4i squared. Multiply what's on the inside, square root of 15. And then the 4i squared becomes -4. And the last one, distribute the negative. This becomes +1 minus 2i. Combine your like terms and I get 5 plus 4i. All right, you may have got this one before, or you may get it later. I can't remember if I used this one or not. But how do you make Lady Gaga mad? Poker face!